we have to go over, and then it's review, 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 right? Your test is when?
Wednesday.
Good thing McLemmon doesn't even know, because that's a Saturday. All right. Yes, it is Wednesday. Okay. So when we see questions like this, we have to set them up in a specific way, and then the question is really, really easy. So let's look at this. It says, the odds that Ava will pass math this semester are 4 to 1 in favor. Let's make a probability out of that. 4 to 1 in favor of passing math. So which one of those is passing? The 4, because in favor comes first, and this one is not passing. So we can go Ava. Probability of Ava passing math is what? 4 out of how many? Odds always add to what? Total. So it's 4 out of 5. The probability of Ava not passing, not pass math, not proper English, don't really care, is what? 1 out of 5. So we can get that from the odds. Do you agree? And then the odds that she will pass English this semester are 1 to 9 against. So pass English, 1 to 9 against. So which one of these is passing English? It's the 9, because it's against. So whatever word comes second, right? So passing English. So this would be her passing. This would be her not passing.
Why is there the against that?
Because the against tells you that whatever it is comes second. When you pass English, against means whatever is in the words comes second. In favor comes first, against comes second. So if it's in favor of passing, then passing would be first. This one's passing English against, so it would be passing would be the second. Against is second, favor is first. All right. Pardon? It needs to be there so that you know that passing is the second one. If it was favor, passing would be the first one. Probability she passes English is what? What's the probability she passes English? Which one's passing? 9 out of 10, because odds goes out to total. And what's the probability she not pass English? Like me, who's writing not pass English. What would it be? 1 out of 10. Now I'm going to show you how you can do it without a tree diagram, and then I'm going to show you how you can do it with a tree diagram. As long as you write out all of the options, so passing math, not passing math, passing English, not passing English, you can do it without a tree diagram, or you can do it with one. So we're going to do it without first. So here it says, if these events are independent, which means you can just multiply them and it's done, right? Dependent would mean you'd have to like take off one of the denominators or something, right? So these events are independent. Determine the probability to the nearest hundredth that she will pass math and English. Okay, what's passing math? 4 out of 5. And means I multiply what's passing English. 9 out of 10. Multiply and reduce. Go. What are you going to get 18 out of 25? The next one says passes math and not English. So math passing is 4 out of 5, and is multiplied, and then not passing English. 1 out of 10. What's it going to be? 2 out of 25. The next one is passing math or English. Math or English. So if they pass math or English, pass math would be what? We should say pass math or English only. That's what it should say. So math is 4 out of 5. But if they pass math or English only, if they pass math, they're not allowed to pass English. So what would it be? 4 out of 5 times 1 out of 10. So this would be passing math, not passing English. Or, plus sign, passing English. What's that? 9 out of 10. And not passing math, which is what? Let's type those in. What do you get? 13 out of 50. This one says express the odds in terms of probabilities. So we've done this already. Probability of passing math was 4/5. Probability of not passing math was 1/5. Probability of passing English is 9/10. Probability of not passing English is 1/10. Remember, don't use short form on a test, right? I'm using short form now because it's not a test into your notes. On a test, I would write probability of not passing English. Okay? So instead of actually doing it this way and figuring it out this way, where you times them or you take 2 and you add them and then you multiply them, bless you, bless you, we could make a tree diagram with the outcomes. Just like we do a tree diagram with like coins, correct? How we did a tree diagram with coins? So what you could do is you could go do this as the math part of the tree diagram, and this is the English part of the tree diagram, just like with coins. You know when you have coin 1, you do heads or tails. Coin 2, you do heads or tails off of the heads or tails. It's the same thing here. So math, this would be passing. So passing math is 4/5. This one would be not passing, which is 1/5. And then for the English, what would these ones be? Passing, not passing, passing, not passing, right? Because you could pass math, then pass English. You could pass math, not pass English. You could not pass math, pass English. Not pass math, not pass English, right? It just gives all the different outcomes. So this would be passing English, which would be 9 out of 10. This would be not passing, which is 1 out of 10. This would be passing, which is 9 out of 10. This would be not passing. This would be 1 out of 10. So I would get 4/5 times 9 out of 10. And I get 4/5 times 1 out of 10. And I would get 1/5 times 9 out of 10. This would be 1/5 times 1 out of 10. And I write all my answers. This one was 18 out of 25, we did it up top. This was 2 out of 25, we did it up top. This one's going to be 9 out of 50. This one's going to be 1 out of 50. If you do the tree diagram, like I've said before, it is somewhat time consuming. However, it gives you all the answers you could possibly want quickly. So if I just say to you, what's the probability of her passing math? That's it. Just passing math. I don't say she can't pass English. I don't say any of that stuff, right? Just what's the probability of her passing math? So then I find all the places where she passes math and I just add them up. So if I say probability of passing math, which ones would I add up? Which ones does she pass math in? Simon, what do you think? Anything with the 4/5 in it, right? So which two cases would it come with? Yeah, the 18 out of 25 and the 2 out of 25. In both those cases, she passes math. One, she happens to pass English as well, and one, she doesn't pass English, but I don't care about that. All I asked you was what the probability that she's going to pass math when she writes her next two tests. So you'd go 18 out of 25 plus 2 out of 25 Make sure you put fractions in brackets. And you get 0.8. Or you could get 4/5 is what it would reduce. Which makes sense because it would head back to just the passing math part, right? Now, that one's a straightforward one. What if I say, what's the probability that she passes at least one test? That's where the tree diagram actually comes in. Probability of passing at least one exam. So she could pass one, or she could pass both, right? At least is one or more, correct? So we take all the cases, which I'm going to use red here for. Get off the red. Oh, let's see. Passing. So this is where she passes math. So I would count this case. This is where she passes math. I don't care. She doesn't pass English. This is where she's not passing math, right? But she is passing English. And then this last one, she doesn't pass either test. So that's a problem. We don't count that case, correct? So what cases would we count if we said passes at least one exam? We take this one because she passes both. We take this one because she passes math but she doesn't pass English. And we take this one because she doesn't pass math but she does pass English. So the only one we wouldn't count is 1/10. So we go 18 out of 25 plus 2 out of 25 plus 9 out of 50. We should get 0.9. No, 0.98. Oh yeah, because this would be 1/50th. And it should be 0.98 because the only one that isn't counted is this one, the 1 out of 50, right? And what should total probability add to? 1. So if I go 1 minus, the only case that doesn't count, 1 out of 50, I get 0.98. I get the same answer, correct? So I can either add up all the cases that do fit, Or I can take 1 minus the cases that don't, and I'll still get 0.98. All right? Okay. I want you guys to do this one. In a game of field hockey, the probability the Dinos score for any short corner is 1/8. So probability of scoring from a short corner is 1/8. What's the other one? Probability of? Yes, not score. Which would be 7 out of 8, correct? So every time they kick from the short corner, they have a 1/8 chance of scoring, probability, and a 7/8 of not. We agree? So here it says, during the first half of the match, they're awarded 2 penalty corners. So this would be penalty corner 1. This would be penalty corner 2. And what could they do when they come out of the penalty corner? They can score or they can not score, correct? So penalty corner 1, they could score. What's the probability of scoring? 1 out of 8. Or they could not score. What's the probability of that happening? 7 out of 8. Then what options do I have on these two? Score and not score. What options do I have on these two? Score and not score on the penalty corner 2 kick, right? So I have score, which is 1/8, or I have not score, which is 7/8, or I have score, which is 1/8, or I have not score, which is 7/8. Okay, go away. Or not.
Yeah, I really used
Yeah, but it's showing the big one. Do you see it? Now it's back to small. It's saying it's not big, but then it draws it big. That's what it wants. Yeah, that's what it wants. So for the first one, the first option I have is score on penalty corner 1, score on penalty corner 2, correct? Score, which would be 1/8 times 1/8, which is actually 1 out of 64. So it's a small probability, and it should be, because it's a small probability they're going to score. Now to score twice, it's going to even be smaller. The next option I could have is score on penalty corner 1, not score on penalty corner 2, which is 1/8 times 7/8. Which is 1 out of 56. Ooh, 7 out of 56 to 1/8. Ooh, this should be an 8. 1/8 times 7/8. Yeah, it's just 7 versus 4. Then this one is not score, 7/8 times score, 1/8. It's 7 out of 64. And then not score is actually going to be the highest probability out of the 4. Which is 49 out of 64. Now, since you filled this in, I want you to answer the questions. So here it says, use probability tree diagram to determine the probability that from these 2 short corners, the Dinos will score 2 goals. What's the probability of scoring 2 goals? What's the probability of scoring 1 goal? What's the probability of scoring at least 1 goal? What's the probability of scoring no goals? And you can pull it right from this chart. Okay? You try it out. What's the probability they score 2 goals? What's it going to be? Anyone know? 1 over 64. Score, right? Just the top. 1 out of 64. Score 1 goal. So if they score 1 goal, it's going to be the score not score or the not score, correct? So it's going to be 7 over 64, or means add 7 over 64, which gets to me what? 7 over, sorry?
32.
Thank you. and then at least one goal, we can do this two ways. We can add up where they score one goal or more. So it would be 1 out of 64, which is 2 goals, 7 out of 64, which is 1 goal, 7 out of 64, which is 1 goal. And what do I get? Or I could just go 1 minus the only case that doesn't fit, which is the 49 out of 64, right? Which is 15 out of 64. Same answer. So I know I'm right. And then scoring no goals is not score, which is 49 out of 64. So I do know that the tree diagram takes a bit of extra time, but you have every answer very easily after you're done it. Flip over, you have one more to try on your own. So try that one out. It's Connor's playing a weekend trip. He considers canceling the trip if the weather is wet. The probability of a wet day is 0.3, and the weather on each day is independent. So this would be day 1, day 2. If the weather wet is 0.3, what's the weather not wet? 0.7. Yeah. So this would be wet would be 0.3, and then wet would be 0.3. Wet and then dry would be 0.7. And this would be dry, which would be 0.7. And then say it rains, so it's wet, which is 0.3, or dry, which is 0.7. Either way, we're going to get 0.3 times 0.3, which is 0.09. Or we go 0.3 times 0.7, which is, or we go 0.7 times 0.3, and because multiplication is commutative, same answer. Or 0.7 times 0.7. What should those all add up to? 1, right? If you have every single probability you possibly could have, it should add up to 1. Okay, what's the probability that both days will be wet? What do we get? 0.09. Boom, we're done. Because we did the tree diagram, we did all the hard work, right? There will only be one wet day, only one wet day, so I can't include the 2 wet days and I can't include the 2 dry days, correct? Only one wet day, so the first day could be wet, but the second day has to be dry, which is 0.21. Or plus sign, the first day has to be dry, the second day has to be wet, which is 0.21, which is 0.42. He decides to cancel the trip unless the odds of 2 days dry is better than the odds against. So, how many days is there? What's 2 days dry? 0.49, right? So it says he decides to cancel the trip unless the odds of the 2 days dry is better than the odds against it. So odds dry would be, how many? Dry is 0.49, correct? So that would be dry. What would be not dry then? When you have probabilities, what should this add up to? 1. So what's dry? I mean not dry. 0.51. And if you add up the other 3, 0.21, 0.21, 0.09, you do get 0.51. Is it dry more than it's not dry? No. So should he cancel his trip? Yes. He should cancel. He should cancel his trip. Okay, for the last bit of class, I'm going to get you to flip to the very back, not very, very back, but you're going to, does everyone have this? You're going to flip to, you're in the right spot. Yeah. So it's called Chapter 3 Exam Review. Start going at it. Chapter 3 Exam Review. I don't have that available, but it's Chapter 3 Exam Review. So flip ahead a few pages. At the top, it's titled Chapter 3 Exam Review. It has a Venn diagram on the page.